In 1913, Niels Bohr proposed atomic model of atom. His model was based on the atomic spectra of hydrogen. He retained the basic concept of Rutherford. He applied Planck's quantum theory on revolving electron. Bohr's postulates: 1. Orbit or energy level. 2. Size of orbit. 3. Stationary orbit. 4. Quantized orbit. 5. Energy change of electron. 6. Radius of orbit. 1. Orbit or energy level. The electron revolves round the nucleus in a certain fixed, discrete closed path called orbit or energy level or shell. Electron revolves round the nucleus with high velocity. 2. Size of orbit. Each orbit is associated with a definite amount of energy. These orbits are numbered as n is equal to 1, 2, 3, 4, etc. and according to letter method, they are represented as K, L, M, N, etc. As the value of n increases, the size and energy of orbit also increases. 3. Stationary orbit. As long as electron moves in a particular orbit, its energy is constant, that is, it does not emit or absorb any electromagnetic radiations. So, these are called stationary orbits. 4. Quantized orbit. Electron revolves around the nucleus only in a quantized orbit, that is, the angular momentum of electron is integral multiple of h by 2 pi. mvr is equal to nh by 2 pi, where m is equal to mass of electron, v is equal to velocity of electron, r is equal to radius of orbit, n is equal to number of orbits, that is equal to 1, 2, 3, 4, etc. h is equal to Planck's constant, that is equal to 6.625 into 10 to the power of minus 34 joules per second. 5. Energy change of electron. Energy is emitted when an electron jumps from an outer orbit into an inner orbit. Energy is absorbed when an electron jumps from an inner orbit to an outer orbit. The emission or absorption takes place in quanta. Delta E is equal to h nu, equation 1. The energy of radiation emitted or absorbed is equal to the difference in energies of the two orbits. Delta E is equal to E2 minus E1, equation 2, where E1, E2 are energies of two orbits. From equation 1 and 2, delta E is equal to E2 minus E1, that is equal to h nu. 6. Radius of orbit. He derived an equation for the radius of orbit. R is equal to n square h square by 4 pi square z e square m, where n is equal to number of orbits 1, 2, 3, 4, etc. h is equal to Planck's constant. Z is equal to atomic number. M is equal to mass of electron. E is equal to charge of electron. For hydrogen atom, Z is equal to 1. Rn is equal to 0.529 into 10 to the power of minus 8 n square centimeter, where Rn is radius of nth orbit. De Broglie's explanation of Bohr's second postulate of quantization. It is very difficult to explain the Bohr's second postulate. It states that an electron can revolve only in those orbits for which its orbital angular momentum is an integral multiple of h by 2 pi times when n equals to 1, 2, 3, and so on. The quantization is why should the angular momentum can have only those values that are integral multiple of h by 2 pi. The question was explained by the French physicist Laux de Broglie in 1923, 10 years after Bohr's proposal. According to de Broglie's hypothesis, all material particles, such as electrons, also have a wave nature. C.J. Davison and L.H. Germer later experimentally verified the wave nature of electrons in 1927. De Broglie argued that the electron in its circular orbit must be seen as a particle wave. In analogy to waves traveling on a string, particle waves can lead to standing waves under resonant conditions. We know that when a string is plucked, a vast number of wavelengths are excited. However, only those wavelengths survive which have notes at the ends and form the standing wave in the string. In a string, standing waves are formed when the total distance traveled by a wave down the string and back is one wavelength, two wavelengths, or any integral number of wavelengths. Waves with other wavelengths interfere with themselves upon reflection and their amplitudes quickly drop to zero. For an electron moving its nth circular orbit of radius Rn, the total distance is the circumference of the orbit 2 pi Rn. A standing wave is shown on a circular orbit where 4 de Broglie wavelengths fit into circumference of the orbit. 2 pi Rn equals to n lambda, equation 1. N equals to 1, 2, 3, so on. Figure illustrates a standing particle wave or a circular orbit for n equals to 4. That is, 2 pi Rn equals to 4 lambda, where lambda is a de Broglie's wavelength of the electron moving in nth orbit. And we know that lambda equals to h by p, where p is the momentum. If the speed of the electron is much less than the speed of the light, then momentum p equals to mvn. Therefore, lambda equals to h by p equals to h by mvn. And we know that 2 pi Rn equals to n lambda equals to n into h by mvn. On rearranging, equals to nh by 2 pi equals to mvn Rn. Equation 2. This is the quantum condition proposed by Bohr for the angular momentum of the electron. Alpha n equals to mvn Rn equals to nh by 2 pi. 1 by lambda equals to r of 1 by 2 square minus 1 by n square. And this equation is the basis of explaining the discrete orbit and energy levels in hydrogen atom. Thus, de Broglie's hypothesis provided an explanation for Bohr's second postulate for the quantization of angular momentum of the orbiting electron. The quantized electron orbits and energy states are due to the wave nature of the electron, and only resonant standing waves can persist. Bohr's model involved a classical trajectory picture and correctly predicts the gross features of the hydrogenic atoms. Hydrogenic atoms consist of a nucleus with a positive charge, positive Ze, and a single electron, where Z is proton number. Examples of hydrogen atom are singly ionized helium, doubly ionized lithium, etc. In particular, the frequencies of the radiation emitted are selectively absorbed. This model, however, has many limitations. 1. The Bohr's model is applicable to hydrogenic atoms. It cannot be extended even to 2 electron atoms such as helium. The analysis of atoms with more than 1 electron was attempted on the lines of Bohr's model for hydrogenic atoms, but didn't meet with any success. The fact is that each electron interacts not only with the positively charged nucleus, but also with all other electrons. Bohr's model involves electrical force between positively charged nucleus and electron. It doesn't include the electrical force between the electrons, which necessarily appear in multi-electron atoms. 2. Bohr's model correctly predicts the frequencies of the light emitted by hydrogenic atoms. This model is unable to explain the relative intensities of frequencies in the spectrum. Bohr's model unable to account for the intensity variations. Bohr's model could not explain complex models for complex atoms. We have to use a new theory based on quantum mechanics, which provides complete picture of the atomic structure.